machine. This here. Okay, and then this you have the rack, and then you have this the container or the box. This now so this machine would like to retrieve. Yeah, this another retrieve, move. Okay, this store. So you see the advantage if you use ASRS. So now we have about 25 students. Okay, so this, now everyone hears me speaking. Everyone hears I speak. Okay, you can type in on the chat. I can check. Okay, so hello. This- Okay, so yeah. So now so today I will present this the ASRS, like that this automatic store retrieval system. Okay, so because we lost it 2 weeks, the first Orica and the last week no class. So like that this maybe we we need the makeup class. Okay, like that this later. Now the before uh, I would like to review on the definitions of automatic store system. Okay, and then talking about the ASRS and carousel. First, this header, I will focus on the design ASRS. Okay, yeah, uh, because we use this now, so we use online classes, so like that's it is difficult for explain. And then so sometimes I will use the YouTube. This you watch the you watch the operations of the ISRS, and then I will explain the equipment. So this is for you. Okay, so this is the first the storage system. The storage system, so you know the storage materials, maybe parts of working process, finished goods. Okay, some things this, and yeah, this performance measures. So you see that this the capacity. Yeah? The capacity. So like that, this you need to measure the total volumetric space and the total number of the storage compartment. Like that, this a unilock compartment. This is the first. Uh, as I explained for user compartment. cái cái ngăn nhỏ trong cái trên cái rack compartment. And this performance at the store is density. Density, so like that's it is talking about the volumetric space available for stores retrieve and accessibilities, and systems throughput. Okay, so these are systems throughput talking about how rate of the storage and or the retrieval transaction and is a performance utilization and availability. Okay, so and we have the two strategies for storage. Is the first the randomized storage and dedicated store. You know that it's the random if so incoming items are stored in any available location and dedicated dedicated store. So like that is you yeah assign to specified locations in store facility. Okay, so this and the conventional storage methods that you have, maybe you use the pool storage, rack system, serving and bin and drawing store. You see this the picture here, okay, on the figures. For example, this is the pool storage arrangement. So like that, this you have the characteristics. So maybe this you have if you use a full storage arrangement, high density full storage provides. Okay, this and low cost per square meter, low cost per square meter. And then say this is a pallet loss. Okay, pallet loss placed on rack in multi-rack structure. You see this here, the rack, and this you see is the container or the box. Therefore, it's a store and retrieve. You watch already so on YouTube. Yeah, and the drawers are stored. So like that, it is so it's the same cabinet. Is it? And then so you have the drawer. Yeah, and the shortens and it's automatic storage systems. Of course, and now we consider only the automatic storage system. Okay, so, and then so this you have this objective if you okay and region the reasons for automating the storage operation. Okay, now wait I check this. So, okay, so Okay, so yes, and that's the objective. You see a lot of the increase, improve, and so reduce labor cost as well. So yeah, and this we have the two. So we focus and consider the two type of automatic search stories. So that is automatic search stories or retrieval search system. The brief is we call ISRS and carousel search storage systems. Yeah, and then this here you have the balance here ASRS. So like that, this you see on the picture SR store retrieve machine, and then this yeah you see you watch on Reddit on the YouTube this okay this maybe this maybe pick up the container and move inside store and then some maybe retrieval is yeah okay so like that said this and this you remember so this is the thruster you have the parameter so like I said this you see the length the height okay and the y but here so only is talking about so only is one is maybe you have the wise of the warehouse so like I said you have the next okay this and ASRS application so like I said you have Unilost store and retrieval of core or the beginning is a very important so you know and mini loss and man on board items retrieval that you see this on the picture and work in the processor stores. Yeah. And carousel storage systems you have the two time the first the horizontal and the vertical. You see here. These are for the horizontal. So like that it is you see move horizontal carousels storage systems manually operates horizontal carousel store the system you see here okay and then you have the conveyor and the operator or the workers maybe stay here so like that you have a load or unload station and this you have the pin for the inventory the pin and move so like that yeah this is the conveyor yeah this you have the applications of the carousels okay so yeah this talking about the ASRS this I think that you consider this for so is the structure here yeah you read that reading terminals okay so this here or this cannot move yeah generate structures of ASRS I think this you can understand and now so I review this here you have the Y of ASRS so like that this is the Y of the warehouse and then this is you have this the rack length okay the rack height and rack wide so like that this is for only one this and then you see this is the bay and storage rack chiều dài của kệ chiều cao của kệ chiều rộng của cái kệ cái rack and then this you have the row this you have the row and then the between the two the between the choose the rack you see that this aisle here aisles let us for this for the SR machine move inside Okay, SR move. So like that is the store and retrieval move. The store and or retrieval. Sometimes everybody calls it stacker. Okay, you remember? Okay, so like that is ISO unique. So like that it is the same. The storage rack, the storage space. Okay, and then you see that is that you have the clearance for PD area. PD area because the deposit. Okay, if you focus, you can return this here. Okay, this SR are used for deliver and retrieve materials in out of inventory. Okay, so like that said, this maybe you have an SR store or retrieval machine. Okay, this interpretation is Vietnamese, so maybe you can understand. So like that said, this giống như là một thiết bị dùng để lưu kho và lấy vật liệu ra để thế thôi. Okay, this but you know this SR or stacker machine. Okay, and then this you have an area, so you have the PD station, so like that P pick up and deposit. Okay, so like that, so this you have the clearance for PD area. You know, so okay, so this and then set this as a planner for you. This storage space, store rack, bay, row, IO Unix storage trusses you can. Okay, and then set this you have this the machine here. SR machine is used to move. You see, to move the items in and out of inventory. This is careful available horizontal and vertical move, and raise the systems along on the floor, guys, the machine and the parallel rails. Okay, so and then so you have the model, the storage models. So like that, this DRs, the unique, the unit loss of the container. So you see, so depend the dimension of the compartment, you know, and then so you can design this the model. Yeah, and B this station. So like I said, this is the station also for the inventory or the transfers into and out of ASRS. So like this. Okay, yeah, this you see. So like I said, this is a design. Okay, this SR machine, and then you have a this is the conveyor. Okay, this is the conveyor, and then here you have the software or the computer for management. Okay, and then so like that, this is the same the SR machine or structures machine. So you see, okay, this and this definitions of unit loss ISR is a user story retrieval. Okay, so you raise and then mini loss. Okay, diff plan as a plan. So already and man on board ASRS that you I think that you can see this on here on the picture. Okay, so this is talking about single depth thing. This you see this. Okay, yeah, and this the various systems concept for ASRS. You see, so this the first you have the structure trend, ending, the rocks, and so. Okay, so this now this is very important designs of ISRS. So, like that, this is the same. Like that, this is the same. the conveyor and the AGV. AGV uh, we study in the middle in the mid exam. So like that's this. So like that's this the same. And then I think everyone understand on, and then this you can consider for the example because it is an example. So like that you can understand on. Okay, so now this is the first because this you see this is the theory, yeah, a lot of loss sign determination. So like that this determine the loss sign. Okay, this important. This okay. So like that this is the here the on workflow information, the movements of frequencies, the back tune, the features, the balance or the supply, the file overall workflow. Okay, so like that, you have the, this is the new definitions workflow. Okay, so now workflows it determines by varieties and the volumes of the parts and the time of a production of the system. So like that, this you have the wide and the height of the thrusters of the ISRS. You see, this you see on the thruster. Yeah, this the dimensions of the uniloss with the proper clearing provides an individual storage space dimension and a scale for the size of support the beam in the rack the thruster. Okay, and so storing the units items unusual and the complexes separate as exclusive from this. Okay, so you see that this why we have the unit the propose the clearance provide because when you store or retrieve the loss the unit loss in the, the compartment and then so you need the clearance provide for. Okay, so this now so here so you see for example this is this is the compartment and then you store this is the container or the box or uniloss inside uniloss inside and then you need the clearance or the gap. Okay, this okay this at the top and the side or and that's a, because this you see the pallet maybe the two-way or four ways that you need that the forklift for store or retrieval. Okay, yeah, so like I said this you have the parameters for calculate this. Yeah, okay, so now it's a calculating individual storage space dimension. Okay, so this a less LP and SP, the length, wide, and height of the unit loss. Okay, and the capital L, length, wide, and height of the raster of the raster. Okay, you see the raster. Okay, is the big first. This on the unit loss you have. So like I said, this the container, the small container, also the small box. You have the dimension. So like I said, this is the length, the wide, and height. Okay, so like I said, this you have the formula. This is the P trains, the dimension of the unit loss and the rack. So you see that this here and the number of the compartment. Okay, this is the compartment. This is you have L here, Y, S. So like that, this depend on the length, the wide, height of the unit loss, and then you have the capacity. You have the capacity here. So this L, Y, and L, Z, Y. Okay, these are the length. Z, these are the height. Respectively, the number of loss of the compartments of the length and the height of I this S and Y. So like that, this you see that this is the number of loss of the compartment. This follows this the length and the height. And S and Y and Z so like that's other one. This into the storage compartment to provide clearance for unit loss to see. Okay, like that's this unit. Okay, and use store depth in the number of unit loss on dimensions maybe this we use in meter like that we use the meter. Okay, so like that this you see here. Now I repeat, of course you if you use this the formula so you can remember. I think so no need to remember, you can open but you use this and then you understand this. Okay, so like that these parameters here. Okay, these are s y z, so like that's a one. Okay, and this use so like that's this the store depth in number of unit loss, number of unit loss, and then and y and z, so like that's the number of the compartments, so all of that is the length. Okay, and total store capacities of one store L is expressed as follows: the capacity per aisle. So you use this as the two. Why? Two. This multiplies because the loss are the content on board of the aisle. You see, yeah, yeah. Now here on board, you see this here, here. This this is the rack. This is the rack surface because this is for the next for the wall. Okay, so like that, you have only this here, here. So like that's the capacity. So like that's this unit multi two, and then so maybe this is the move the ASR machines and move inside this here the next. Okay, you see this is the next here. Yeah. Okay, so like that's a Y. This is you have the two. Yeah. Okay. And then capacity is per aisle is and Y multi and Z. Okay, so like that's this. Yeah. Uh N Y N Y, because it is the storage, the compartment in the land direction, and you have the 10 store compartments the vertically, like that. N Z and Z, you have a two. Okay, so the dimensions of the uniloss, oh, in ink, oh, I don't like it. Okay, so I think that if they give, now I repeat, if the given data set use ink, you use ink, you no need to change the metric. Okay, so like that is the spend time. So okay, and then you have the land 50 and 40 5 y and the 50 high respectively. Okay, and other ones the design is the storage compartment. You have S and Y and Z, you know. Okay, so and storing depth you see storage u in of this u equals 3 determines the capacities per higher and the dimensions of the single storage system. You see the base like that's the solution. Sorry. Okay. We use the formulas. Is the first you see that the capacities per higher, you know. This you know the higher you have the two racks. Okay, this the both side. Yeah, this now you see that this is the two multi and the y so like that. This you have the value 70 and the 10 and that's vertical. Okay, so like that. This you have capacities per higher 1,400 unit loss. Okay, and the next is the dimensions of the single the single storage system. So like that this you use this the formula. Okay, L this, so like that it is the same previous yeah slide. Yeah, okay, easy. And then you in text is the value inside you have on. Okay, so like that this you have to understand, and then you use the rise the parameter of the given data you injected or the formulas that you have. Okay, so like that this for easy. Yeah, okay, so first now, and then the step by step we have another the variable we need determine. Okay, now because that now is a lot of the formula, a lot of the formula. So like that, but sorry, so don't have the ball. I will revise this the formula. So this is for you. So like that said, now I explain, and then I can return this slides. Okay, so okay now estimating storage space number. Okay, estimating. You see, estimating. Ookla knows that determines. Okay, so the store is a special the number. Because we have the two time course and the storage like that's this dedicated and the randomized. Okay, policy so like that's it. Yeah, yeah. are used to determine the number of the storage space. Yeah, okay. If in dedicated storage policy, okay, so like that, this the particular set of a slot is allocated to specific product. Okay, hence this of the maximum inventory levels for enters with the master with the number of slots required to slots the product. Because this is ordered in dedicated storage policy. So the last one. In the last one, so I explained so for you today dedicated so maybe we can understand if là dành riêng du kho chỗ dành riêng cái nào ra cái chỗ đó if no random. So in case random so storage policies you see so yeah okay yeah likewise it is equals a chance of each of the particular product to be retrieved when a retrieval operation is performed. Okay, so like that's it is the name. Okay, estimating storage space. So like that's it is. Okay, and next estimation estimations of AS the throughput, okay, and the number of ASR machine. So like that it is very important. You remember, you remember before we have the so like that it is the same the determines the number of IGV, the number of the IGV. Now we so like that it is the same the number of AS machine. Also, maybe you can give us the question. The question: oh, if we have, if we have the number of IO, so like that, this is you have the same. This is the number of AS machine. Okay, so like that, this is of course, but this depend. You see, this depends on throughput. Okay, so you see later. This the systems that throughput defines how is the result. Okay, so this, okay, hourly rate. This you see this follow. This is the hourly rate of the system, and so this AS transaction SR transaction. So like that's the number of losses stored and the number of losses retrieval, and automatic storage systems can perform. Yeah. So like that we have the dual commands cycles use increase the throughput, things reduce travel times per transaction. Okay, so you will understand this is why this is the dual command and the single humans. Oh, okay, later I will explain. So like that's the so now maybe you can understand if the single command let us say this you have only function one function so like I said this maybe is store only store and if you store and then so you returns come back and you retrieve okay it's one function and the dual command the first maybe you can store okay go choose the location and you the machine store and move the next location you retrieve the container and go to the PD area okay so pick up and deposit station so okay so later you can understand this Yeah, this here you have this the parameters velocity of IS machine structure. Velocity, okay, the single and Bjorn's common cycle, okay, I explain for you, okay, later. And system utilizations per hour, utilization per hour, arrangements of a store item, and speed ASRS control system, speed and efficiencies of the material handling equipment. So, like that said, you have the number of ASRS can be determined now. You remember because maybe in the handout, so maybe have the problem this one, okay, this. So, like that said, this the same number of ICV. Now, number of AS machine equal systems of the robots, okay, and devices. So, this machine capacity is in the cycles of okay. So, like I said, this you have the systems of the robots and device, the throughput of the capacity and the capacity of the machine. So, like I said, this is the same determines of IGB. The first unit calculation. Okay. Now, okay, so these are the third estimating the size parameters of a store and retrieval size parameter. Okay, now because these are the first the throughput and the number of ASRS and the storage space, the number. Okay, so now this the size parameters of the store and the retrieval systems. Okay, system length, wide and height of the returns to estimation the size of ASRS. For this purpose, is required to determine the following parameter. Now, the first you see, okay, so because it is a loss of the word, and if you can cannot remember, so I return this at the slide. This is okay, so no problem. So the first, the number of row, the number of row, and the number of basic. So the system. Okay, so the because the number of SR machine used to store and retrieve materials depend primarily on the system's throughput and the cycle time. These are used for one series mode IO. Each IOs have two rows, you know. Each IOs have two rows. Okay, so like that's before. Therefore, the number of rows case of one SR machines per hour. So like that's this you have. Okay, this the number. So okay, so the number of rows, the number of rows in the system, the number of rows did you know? So this is the thrusters equals to the two multis the number of ASRs in the machine. You see the number of rows and the number of bay. This is the number of the storage space required. The number of storage space required. And divide the number of rows per SR machine multi number of RS machine multi. You know, so this is the number of rows. This is the number of machine and number of storage space per system I. Okay, so like I said, this is you have the number of bed. The number of store space per system height you have this is the system devices also element. Okay, now maybe You focus on this how the row, the bay. Okay, storage space. Now you see this is the thruster here. Okay, this is the bay. You know, this is the row, the row. IO. You see, and space. Now storage. Now you see storage space. The number. You remember? If not, so maybe confused. Now I repeat. This is the number of row. This is the row, the row, the row. The storage space estimation. Okay, and this is the bay, the bay. Next, this you see storage space. It's the three-dimensional space in the store racks used to store a single unit of material. You know, it's a space. It's the three-dimensional space in the store rack. Okay, this is the store rack. Okay, the bay is the height of the store racks from floor to ceiling. Floor to ceiling. Store space. So you see, this is the single. Okay, yeah. This is the row. It's a series of it's a series of places side by side. Here, you see, base, the series of base. This is the row. Okay, this is you see. Maybe you can mix the picture and say this is the rack length. This is the rack length, and then say this is the number of the rows, the number of rows, the number of base. You know, and the number of a storage space. This you see estimation. Estimation. Okay? Yeah. Because I don't have this before, so I can revise this for you. Okay, now this. Okay. Now the next is you have okay the number of row and the number of bay in each row of the system. Now the estimations of phase Y, system Y, rock length, system length, bay depth, and IO unit. Okay, so like I said, this you have the length of the single storage space. Length of the single storage space is added to the send structure support with two calculation by y. Okay, thus we get by y. This length equals the length of space is and plus a send to send plus support y. This you have s s1. S1 is the send to send plus support y. Plus length equals by y is the number of bed. Okay, so now maybe you focus and then you can understand when you read and then I can explain all the example later. So like that, this you have the bed wide is and sister length equals rack length and plus clearance for ASR estimation then of base here. Yeah, because of this the system length is you have the rack length and this and clearance for this machine and this BD areas, pickup and deposit area, and pay depth. So this to the y of individual storage space and plus a pay size support allowance. So you have this is the base size support allowance. Okay, this IOS units equals IOS y and plus 2 base depth. Okay, so later You see on the examples that you can this. So any question? So okay. Okay, so now maybe you can write this on your paper. So like that this. So like that this is the example. This is example. Okay, so now the single command cycle system of SYJ company. So I don't know. So this okay has a cycle time per operation as 2 minutes. So like that this is very important. If you understand this the given data. So like that, maybe you can mistake this as a parameter or the variable. Okay, now this the single common cycle system. So like that, this I told you. Maybe go to only one function, go to for store or retrieval, only one. The single common cycle systems. Okay, and this here the cycle has cycle time per operation as 2 minutes. You know, a cycle per operation as 2 minutes. Expected systems throughput you see expected model for the global corporation is 360 operations per hour. 360 operation per hour. So like that is you have system throughput and hourly. You see hourly. Okay, you're right. The number of storage space. You see the number of storage per system time is the 15. You know the number of storage space per system time is 15. And the total number of store space using random randomized policies is 9,000. 9,000. You see the store space using randomized policies is 9,000. Awesome, awesome storage and retrieval operation take the same, makes the same. Okay, okay. Determine the number of SR machine you see. Okay, so like that, this you need the formula. You need the formulas. Force determines the number of ASR machine. The first the you need the system throughput, and then you need the cycle size of the operations of the for the ASRS, and then you can find this here. Okay, this is the 2 minute now. Cycle size per operation 2 minutes. Okay, and then this you have this system such as throughput here operations per hour. Now this here the number of AS machine equals the system's throughput. You see the throughput and device SR machine's capacities in cycle times per hour. You have the system's throughput here and this capacities per cycle per hour. This you have the 2 minutes. Okay, this per hour, and then you can find number of ASRS. You see this very very clear. Okay, systems robust and cycle size per operation are the 2 minutes. and then you change this out. Okay, you have this. Now the number of row in the system, the rows in the system, you use 2 minutes. So okay, two multi the number of ISO machine in the system. You have the six. Okay, number of rows and the number of page you have here. The number of storage space, the number of storage space required. So estimation you have the 9,000. Okay, and divide the number of row per machine you have two. Okay, this the three, and next the number of space. These are the height. These are the t. Okay, the 15. You know this. The number of storage space, the system height, you have the 15. The 15. Okay, and storage space using the ranking policy. Okay, and then this is you. Now you can check this. Okay, so the number of row per SR machine. You have a okay, so like that, this is the two. Yeah, yeah. Okay, so like that, so you can check this. Yeah. So sometimes if I think that this maybe you can mistouch the features this the rows and the bay. The row maybe is you mistake with the the length and the base maybe mistake with the height. So for this the determine the number of rows. The determine is the number of bay. Okay. Yeah. Now we are okay, so we take a break. Okay.
The automation of storage and material handling systems has evolved over time and has adapted to the demands of an increasingly fast and demanding market. Automatic storage systems represent a revolution in the way of conceiving material handling. Operators receive the products at their own workstation and can also exploit other important tools to search, trace, and ensure the safety of goods. Automatic storage systems bring numerous benefits, reducing the size of the warehouse and thus improving business efficiency from all points of view. Pareto Group solutions provide a high added value for all storage, handling and filing requirements and apply to all product sectors. Pallet stacker cranes allow pallets to be stored on a single or double depth racking using telescopic forks and on multi-depth racking using shuttle systems. They are guided by supervision software and can reach up to 40 meters in height, handling loads of up to 1,500 kilograms. Mini-load systems are stacker cranes that handle individual plastic and cardboard boxes at high speed using telescopic forks or suction cups. They can reach up to 25 meters in height and handle up to 500 kilograms. Special automated storage and retrieval systems stand out for the variety of goods they can store. Loads range from 5 to 5,000 kilograms and are handled using telescopic forks, dragging devices, suction cups, and special shuttle systems. Flexi is a shuttle system capable of handling multi-depth pallets on racking. It can operate with a variety of standard pallets and at temperatures that cover every working environment. It can work both in offline manual mode and connected to the enterprise management system, handling pallets up to 1,500 kilograms. FastRing is a high-performance shuttle that connects the front of the automatic storage system to the picking bays and to the warehouse entrance and exit lines. The conveyors can handle pallets, packages, boxes and coils with loads from 5 to 5,000 kilograms. They are equipped with weight, shape and load identification systems such as RFID and barcode readers. Pareto Group supplies integrated logistics solutions from design through to after-sales service. All its solutions are made in Pareto Group. Every product is designed and built in-house based on the customer's needs. Our experts work alongside the customer throughout the life of the system, providing remote service and continuous technical support. WMS EJ-Log was developed by the Pareto Group R&D team over more than 6,000 hours. Its continuous evolution ensures maximum system efficiency and simplifies management for customers. EJ-Log can be integrated into any company ERP, monitoring in real time and remotely the thousands of part numbers that our systems manage on a daily basis. For Pareto Group, efficiency, reliability and innovation are always at the forefront. Pareto Group. Every solution, just one provider.
Yeah, okay, thank you. Now, sorry. Okay, now so it's okay, okay, so, okay, thank you. So, yeah, this is a single, this, yeah, this is, you use only the store or the retrieval operations, only one, yeah, in case of the store the cycles, machines pick up a loss, travel to the store location, deposit the loss and return empty to BD station, pickup and deposit station, area or station. You see? Okay. Similarly, in the retrieval cycles, the SR machines begin at the BD station and travel empty to the retrieval location. Thereafter, is to pick up the lost, travel to the BD station and deposit the loss. Okay, you know. Okay, so that I think so. These are the single. Now I'll repeat. If the store, okay, the machine lost, pick up machines pick up a loss, move to the store location, deposit the loss. Okay, deposit the loss. Okay, so store maybe it's store and return empty. If retrieval cycles, the first the machine as the BD session and move empty to the travel empty to the retrieval location, and then it's a pick up for the loss. Okay, so travel to BD area and deposit the loss. So and then you owns a common cycle. You owns a common cycle. The cycle is determined in case of a Dion's common cycle. So when it starts its operation with machine as PD station, okay, this last here, the machines pick up the loss and travel or move to the store location to push down or unlock the lock. Thereafter, thereafter, the machine travel to the retrieval location to recover the lost. Final is a driver back to the B station to deposit the loss. You know, okay, so like I said, this everybody you want a command, you want command. The first store, and then go to the next location for retrievals and go to the PD station and unlock for the deposit the loss. Okay, now this I think that is the very important with the parameter. Yeah, these are the parameters because these are for this assumptions already. So like that. Simultaneous horizontal, okay, horizontal and vertical travel for the single common cycle, the loss to be entered or retrieved assumed to be location at the center of the block structure. So for this the field, you see, sorry, this, okay, you know, so like that, this is a horizontal and vertical travel. Like that addition. Now you see this figure A, single common cycle. This the simultaneously the horizontal and vertical. Ok, cùng một lúc di chuyển theo chiều ngang và chiều đường. For single common, this is the loss to be entered on the retrieve is assumed, you see, assumed to be located at the center of structure, the center. So, like that, this you see, this is the high, a hand high, a hand length of rock. You see, remember, so like that, this assume, assume. Thus, as our machines must travel half the length and half the height of ASRS, and it must return the same distance, The single common cycle time can therefore be expressed by here. Okay, so you see this later here. Okay, so this here you have a TSC. This is the cycle time of the single comment. Okay, cycle time of the single comment. This length L is the length of areas of structure, and V, Y, and VZ. So like that, it is a velocity of the SR machine along the length of AS and S is the height of the rest of the thruster. And VZ is the velocity of AS machine in the vertical directions of ASRS you see. Okay, and then you have the length and the height of the thruster. Okay, and this TBD. So it's the pickup and the deposit time. The pickup and deposit time. Two pickup and deposit time are required per cycles. Please presenting loss transfer to and from SR machine. This from a machine. So like that, this you can use this the formula. The cycle times of a single comment is the max, or you use the max is and plus choose BD. Okay, this now and this the Dion command the Dion command. This you see here. Let us this the sign as the PD station. Yeah. Okay. Move. This is the center. For this maybe this the store okay. This is the store. So like that this sorry. This is the same the single the single command. This you have a hand the length and a hand the height. This and then go to next. Okay, go to next locations for retrieval and then awesome. So awesome. So you see once above 4 length this here. Okay, and this is the same once above 4 height. This go to this location. So you see so this is awesome. Okay, awesome. And then if retrieve already case and return. Okay, returns this to BD station. You see, like that, the distance equals this distance for the store, and this empty to go to this for the retrievals location, this plus this. Okay, okay, so like that, this you see here. Now explain, so like that, this the same for the ones common cycles. The SR machines is assigned to the travel to the center to rack, the center to rack the thruster to deposits are lost. So like that, this is the four store, and then the three quarter, the three quarters, the length. So like that, it is only so we choose once per force length, and the height is a retrieve loss. The total distance travels by SR machines equals to UC is the length. Like that, it is the same. Yeah. Okay. So this you have the formula the CD. Okay. Cycle time of dual common. Okay. This, and then you use this formula. So like that, it is the same. But this you can text this. The chance that this this is the value here. Okay. This is you remember this is you choose this is the mark, the picture, and just choose the value. Okay, so you have to see. Yeah, very easy. So because of this now this awesome. Okay, so like that, so this maybe this here. Okay, no, this a hand of land. No. Okay, so like that, so this is for awesome. No problem. This. Okay, the system's throughput. The system's throughput depends you but the both analytics of the single and dual command cycle. So that's RCS may be set as the number of single commands the cycle performed per hour. Okay, R right there. While RCDs may be set uh, the number of your command cycle per hour. You know, so like that is the number of the command specify or assumes utilization level. Thus, the amount of time spent in the performing a single command and during the command cycles is ours. Okay, amount of time spent in the performing single and during command cycle is ours. You use it is the formula. Okay, RSCT RCST CSF plus RCD multi T CD is equals to CT U like that is system utilization the hours during the hours. You see the right hand side, the right hand side of the equation give the total number of minutes of the operation per hour. Okay, for this equation we need the determine the relative proportion, the four RCS and RCD. You remember. Okay, now I repeat the right hand side, the right hand side of equations give the total number of the minutes of the operation per hour. For this equation, we need to determine the relative proportions for RCS and RCD. Okay, assumption now. Assumption about these proportions must be made when shown from the total on its cycle is given by here RC. So like that is you have RC like that the total SR cycle rest cycle per, like that's this is unique cycles per hours, hours plus 2, right? Okay. Note that the total number of the store and retrieval transactions per hour will be greater than these values unless RCD equals 0. Okay, if it's single, saying there are two transactions are accomplished in its dual common cycles. As you have the TRT, the total number of transactions, the totals of the transactions performed per hour. You have here. Okay, depend. See. Now I repeat. This you have assume about these proportions must be made. We saw when shown the total hours cycle rate if by you have RC. RC like that's a total the cycle rate SR. Okay, cycles per hour. This the total number of store and retrieval transactions per hour here will be greater than these values RCD equals 0. Okay, so this saying there are two transactions accomplished in each neuron. Two transactions accomplished in each neuron's common cycle. You have RT, like that's the total number of transactions performed per hour. You have okay. This now is a very important. Is example. This example so now sizing and ASRS system. Now you can revise this given data. Is now that's a question. Is L of 4 you maybe everybody everyone forgot this 4 else ASRS. You see 4 is L of 4 ASRS contain city store compartment. You remember the compartment. This here for each arrow, you know, no for in the land direction and 12 compartment, the vertical. Okay, the land you have the city compartment. The vertical you have 12 the compartment. Okay. On store compartment. On storage compartment are the same size. You see, the same size to accommodate the standard size palette of the dimension. You remember when you design the palette, you have to use the standard size palette. So like that, this is the same the midterm exams. A lot of the student you propose the new design, the dimension of the palette. So like that, it is the wrong because this you have the standard size. Maybe you can use okay here 42, 48 inch. This you know that it's and Y and height of yeah. So this is the compartment. You have the S and the Y and the height of the uniloss. You have the Z. Okay. This is the 4 the compartment. using R1, using R1, this A and B and C. So like that, this you know, this the clearing. Now determine how many uniloss can be stored in the ASRS. How many uniloss can be stored? This and y length and the height of ASRS. ASRS. You know? So everyone know this is arrow. This arrow contains this here 60 compartment in the land and 12 compartment in the vertical. Okay, on storage compartment, this you have the same sign accommodates the standard size pallet and the height of the uniloss here. This and you have the other one. This how many uniloss can be stored ASRS. So like that, it's you see here because it's the compartment you use for one uniloss. Okay, so like that, this I think because this don't have the formula. You see now, you see here is the storage capacity is by the equation. It's a capacity per error. You have here this capacity you have 1,440 uniloss. Okay, because this is for only arrow. This with the 4 arrows you need the multi 4 like that. So like that. A lot of error, a lot of everyone forgets this is the 4 arrow. This maybe this like that is wrong. If you don't multi, this is the 4 arrow. So like that is the wrong. This is here is wrong. You know, okay, because this and from the equations, the dimensions of a store, the trusses can be computed. So, like I said, this is you have the and the high, this is the y. This, okay, this is you have here. This y overall. This is the y as this is you for. You see this. Okay, why? Do you know so why this in here? This is the one multi because it is overall. Okay, this is the 4 and then a high. So this here. Okay. Okay, no question. So now this the first example is the sizing of this the size of the ASRS system. Okay, example 2 is a throughput. Okay, throughput. Now this is consider ASR from example. Okay, we can take this as the value of the example 1. In which answer as machine is used for its arrow This report is L. Sorry, side. This, sorry. In which SR machine is used report is L. The length of the story, yeah, the length of the store IO you have, the height, okay. Suppose horizontal and vertical speed, so like that is velocities of SR machine you have, okay. Horizontal, this, and vertical here, respectively, okay. You have the horizontal and vertical velocity or speed. The SR machines require 20 seconds to accomplish okay, a PT operation. You remember this at that time. Now, determine the single common endurance common cycle time per hour. You know, it's per hour. Is you have to determine cycle time of single, okay, and your common. This now, if you focus, you can see the previous slides. This the cycle time. Yeah, yeah. This okay. This I think that you consider. You have this on. Okay, you can find, and then this the drone you have on. Yeah, this you see. The single endurance performance cycle time calculated by equation is you have this, okay, this here 20 seconds. You change this minutes. Okay, this is the length and vertical and horizontal velocity and vertical. Then this is the height. And this is the cycle time during command you can. So of course you can choose this is the max. Okay, maximum, maximum. That's it. I think that is okay. If you have the cycle time, and then determines throughput per hour under assumptions that the storage system utilization is 90%, and the number of single command and joint commands are equal. The number of single and joint command cycle are equal. You know this. The number this here is a you have this a utilization, okay, and then this you have the number of your the number of single ions cycles, and then you have this is the formula. Okay, now you can raise the formula, and then if you have the questions, and then I can explain. Okay, you see the first single comment and the dual comment activity level is also can be established as follows. Okay. Now, the first you use this is the formula. You have DCS, DCR, and then you have the right number. This okay. Now this you have according to the problems statement. According to the problems statement. So like that, this example. The number of the single common cycles equals the number of the dual common cycles. So like that, this thus RCS equals RCCD. Substituting this relation into a for this equation, you choose only one. Now this here, you choose maybe C RCS equal. Okay, so like that, this you have utilization, and then you find this is the number. Okay, this the single common cycle per hour. This and then like that's equal. This is the same dual common cycle hours. Okay, and the systems of throughput is equal to the total number SRS transactions per hour. Yeah, so you have okay this the total number of SR transactions per hour. You have RT equals this here, and then you inject CS, RCS, and RCD or RCS. So like that, so this is the same. You find this, okay, the total number of the transactions per hour. Okay, with the 4L, you need the multi 4. So like that. Because some everyone focus the 4, these 4L's you have. Okay, so this now this varies. Okay, if you have the rules as assumptions as a source. The number of the singles. Okay, so like that, this you can find here. So like that, this you can find this the number of the transaction. So like that, this you this nose. Okay. Yeah. Now, the next edition is talking about the carousel storage system. This you remember is the structures of the carousel storage. Now, this okay. So like I said, this is horizontal. Okay. Now this the top view. This is the top view, and then you have the pin. Okay. This and then this you have the conveyor. You have the conveyor. This you see the top view. Okay, the top view. Then this, and then this you have the side view. Okay, this the land, and then you have the carrier. You have this the pin, and the P and the piece of the number of pins or the designs. Okay, so like that. You know. Okay, this is a horizon, and then this is you have the lost unit or unlost unit. Okay, you take this. You remember, so this is the thruster you have the top. Okay, and the side view, and then so this is there are the pin and this. Okay, now it's a storage capacities. The size and the capacities of the carousels can be determined with the reference to below figure. In videos, bin or baskets are suspended from the carrier that's reborn around and over the rails with the conference given. Okay, so you see over so this okay, like that's this. And then so this you have this circumference is 2 length minus y plus b by equals 3.14. Okay, this is by. Okay, and y circumference of the oven conveyor track. Okay, maybe so this is you have m and length, whereas our length of the watch of the rack. Okay, this the fix you can use meter, or you can use this the meters or fix depend for you. Use this the unit. Okay, now circumference you know. Okay, capacities of the carousel systems depends on the number and size of pin or package you use. This is the pin or package in the system. The number and size of the bin. As some standards, you see, standard size bin are used. It's of the certain volume matrix capacity. The number of pins can be used as a measures of capacities. This the number of pin. You see the number. Very easy. 10. Okay, vertical from its carriers is NP and C. Okay, NP and C is so like that's the number of carrier. Number of carriers around very forest of the rail. That's you have the number of pins. Of course, you multi. Okay, this is the number. This is the carrier. You see carriers. For example, this carriers the number of carriers is NC equal